Let's keep looking at homework 4, picking up on question 12. And it says, what are the quartiles of a distribution and how do we find them? So first off, this is 2 parts. It says 1 part remaining. So the first question, what are the quartiles of the distribution? The quartiles of a distribution are where the data falls. So we have the second quartile is the median, the middle, and then we would say the quartile 1, Q1, is the lower median, would be one way to say that, okay? So it's, if we split the data in half, we find the median, which is also our QT, and if we look at the median of the upper half and the median of the lower half, we'll find our upper and lower quartile. So upper quartile being Q3. So let's look at our choices. The quartiles consist of the mean, median, and the standard. No, that's not quite right. The quartiles are values that divide data distributions into quarters. That's actually pretty good. The quartiles consist of lowest value. No, not the lowest value. The data distribution into 4 sets, each of which is called a quartile. So, what do you think? The quartiles, I'm going to say they're the values that divide the data as opposed to the set. So the first quartile is the bottom. Beautiful. We're going to continue. And the second part, it says, how do we find them? Well, let's look at the fact that we're going to use the word median in these. So the A and B both say mean. So we're not going to use those. We're going to use one of these last two, median. So the lower quartile is the median of the data in the first quarter of a data set. And the second choice is the lower quartile is the median of the data in the lower half. So the median of the lower half is where that quartile is. So we're going to say lower half, not lower quarter. So for this next problem, what we want to look at is we want to look at how to find the standard deviation. I've already filled in these blanks, okay? There is a long by hand process. We did it in our notes on Thursday, but then I also showed you that we don't have to do this by hand. It doesn't say calculate standard deviation by hand. So the question would then be, is there a calculator function that does this for us? And if we go to Desmos, Desmos is the calculator I'm using right here, and we'll see on Desmos that if we click on function, func for function, we'll see stdev as a function. When we click on that, we can literally just type in all the numbers they gave us, the 2, 3, 4, 4, and 6, with commas in between, and guess what? It'll tell us the standard deviation. So right now, all I had to do was type that in. And so I'm going to jump over here, and it says round to 3 decimal places, so I'm going to say 1.483. Excellent. Now, they'd ask me one last question. It says, if all the sample values are the same, then the standard deviation is, okay, so if that sounds confusing, that just means what we're going to do is we're going to switch all these to the same to see, what if they were all 4? We have a couple 4s. What if they were all 4? What would the standard deviation be? 0. Well, that kind of makes sense. What it says is, how much does this data vary? And it doesn't vary at all. It's 0. For our standard deviation. Great. Let's look at number 14. Number 14 says, decide whether the following statement makes sense or is clearly true. For the 30 students who took the test, the high score was 80, the median was 75, and the low score was 40. So the question is, do you think that makes sense? Can you have a high score of 80? I'm going to throw this up here. High of 80, a median of 75, and a low score of 40. Is that possible? And it seems like the 75 is really close to 80, but is that possible? Yeah, that's possible. If you have all these students and you have 80, you have a couple people that get 80, somebody gets 78, somebody gets 77, you got that 75, and still you've just got people with like 73 and 72, and so still you got 75 is pretty much in the middle, and then you have some other person that gets a 40, and that's going to be the low score, and that's okay overall because most people got in the 70s or 80s, and so when we look at that, we say, yeah, that's possible. So let's see what our choices are. The statement does not make sense because the median should lie halfway between. The median is not necessarily going to be exactly between the lowest and the highest. The statement makes sense because it's possible when sorting the 30 scores from low to high, the first value was 40, the highest value was 80, and 75 was halfway between the 14th and 15th. Now, I'm going to just check that right now. But pay attention. The statement makes sense because it's possible when sorting the 30 scores. So with the next choice, it's only different in that it says between the 14th and 15th or the 15th and 16th. And so the question becomes, well, where is the median between 30 numbers? If I start at 1 and go all the way to 30, where would the halfway point? And we know that if we divide 30 by 2, halfway would be 15, right? But that is to say that there's 15 on the top half and 15 on the bottom half. So where would we draw the line? We draw it in between the number 15 so that we have 15 this way and 16 so that we have 15 more above that. Okay, so I'm actually going to pick C on this one. Next question. Decide whether this makes sense. It says the standard deviation for a group of heights. Standard deviation is smaller than the standard deviation for a group of heights from a different age. So it says a group of 5-year-olds, if you have just 5-year-olds, is that standard deviation going to be less than the standard deviation for kids from the age of 3 to 15? So let's think about what standard deviation means. Standard deviation means how much does it vary? What's going to vary more, the heights of 5-year-olds or the heights of kids between the ages of 3 and 15? Well, this is definitely going to vary more. More variation. So I think this is actually a true statement. I'm going to say it does make sense. There's two of them that say it makes sense, B and C. So I'm going to look at what the choices say. It says it makes sense because the range of data for the heights in a group of 5-year-old is larger. Well, that's backwards. It's actually going to be the other way. Number 16. After recording the pizza delivery times for 2 different pizza shops, you conclude that one pizza shop has a mean delivery time, of 46 minutes with a standard deviation of 5 minutes. The other shop has a mean delivery time of pretty close, but a little bit faster, 44 minutes. But they're much less predictable. Their standard deviation is 22 minutes. So you see that they both get you the pizza in about the same amount of time, but this one has more variation. So A says the variations are nearly equal. Well, that's definitely not true. B says both the means and the variations are nearly equal. That's not true. C says the means are nearly equal, but the variation is significantly lower for the second shop. That's actually backwards. I'm going to pick the last one. Second part of this is if you liked the pizzas from both shops equally well, which one did you order from and why? Now, this is not an opinion question. It's actually got a right answer. So let's read them. Choose the second shop because it's more reliable. Well, that's not true. The second shop is more varied. Choose the first shop. They're more reliable, and they have more reliable because it has a lower standard deviation. That's true. So I'm leaning towards B. It says choose the second shop. They're more reliable. No. We already talked about that. A higher standard deviation does not mean they're more reliable. It means there's more variation. And last one, choose the first shop because they're more reliable because they have a lower mean. Even though they average 46 minutes instead of 44 minutes, they are more reliable. So I'm going to pick the first shop because they have a lower standard deviation, not because they have a lower mean. All right, next up, a report claims that we have investment portfolios with a single stock, they have a standard deviation of 0.52, while the other portfolios have a standard deviation of 0.332. So this one is our single. This is for 31 stocks, okay? So it doesn't tell us the mean. It just says, explain how the standard deviation measures the risk. Well, if we look at these two, which one is more varied? Well, our answer is going to be the one with a bigger standard deviation. Which one has a bigger standard deviation? This one is 332, but we need to remember that when we're looking at two numbers, we need to look at the place value. If we compare them like this, we say, well, 0.5 is definitely more than 0.3. This one has more variation. So let's look at the choices. A lower standard deviation means more certainty in the return and less risk. Hence, the returns for portfolios with 31 stocks have less risk than the ones for a single stock. I kind of like that answer, but they could just be making stuff up, so I'm going to read all of them. B, they both have the same risk because the difference in standard deviation is too small. I don't know. I wouldn't necessarily say it's small if we're dealing with investing money. You know, a different in percentage rate would make me feel like it might be big. Compare the ratio of the standard deviation to the number of stocks for each type of portfolio. If the ratio is smaller, the risk is higher. Okay. Hence, the return for portfolios with 31 stocks have more risk than the ones with a single stock. I don't think that makes sense because it says that this one would have a higher variation, and it doesn't. D, compare the ratio of the standard deviation to the number of stocks for each type of portfolio. The ratio is smaller, then the risk is higher. Hence, the returns for portfolios with 31 stocks have less risk. Again, I see what they're going for here, but I'm going to stick with the standard deviation. A lower standard deviation means less certainty in the return and more risk. No, I'm going to say that the more variation, the more standard deviation, the more risk. So all those, really, this can get nitty gritty because you're like, I'm not a stock trader. What do I know? So I'm saying that the only thing I know about is the standard deviation. And so I don't know that necessarily investing in 31 stocks is better just because it's more stocks. But I can tell you that based on this data, the standard deviation, the variation is less. So the lower standard deviation seems like it would be more certainty in the return. All right, number 18. These graphs are tough on these because sometimes they're not as precise as I'd like them to be. So it says make a bar graph, but we don't have to actually make it. We're just going to pick one. And it wants the bars in descending order. Descending means what? Well, it means going down. So I'm going to rule out a lot of these because they're not in descending order. The only ones that are in descending order are B and C. B or C. So when I look at B or C, those are the only ones where they're going descending. And what order should they go in? Well, the states A, B, C, D, E should be in that order. A should be the highest population. And so I'm going to pick B because it's the only one that really matches my graph. Number 19, we're going to try to match our graph here. It says the annual revenue, and it's shown in the table. And if I look at this, we've got pie charts. So when we look at the pie charts, what we want to try to figure out is which ones match. It definitely should have the biggest category should be A. The biggest category should be A. And if I look, which one has the biggest category A? Well, when I look at my table, they're in millions of dollars. But when I look at my graphs, they're in percents. So if I could just figure out what percent matched up with A, then I could figure out which one was the right answer. So let's do that. Let's say A is 53.6 million. But if I want to know the percent, I got to put the total on the bottom. So that means I have to add up all those other things. I'm going to pull up my calculator. I missed it. Pull up my calculator. I'm going to go ahead and type in the 53.6. And then on the bottom, I'm going to write, well, I have to include 53.6 in my total. I'm keeping all this in the bottom. If you have a different calculator, you might need to put parentheses, or maybe you might need to do this addition separately before you make your fraction. All right, let's see. There's my 5. I think I typed them in right, and I got 0.34. So if we think about that as a percent, that should be 34%. So looking at my choices, there's actually 2 of them that say A is 34%. But, just switching over to my scratch paper here, only 2 of them say A is 34%. C and E both say that in the key. But when I look at the size of the blue, because A says it's supposed to be blue. I'm sorry if you're colorblind. This should be a really frustrating one if you're colorblind. If you see which one it's supposed to be, the C, the slice is too small. It's only like a little one. So we're going to pick E because it's a better percentage, okay? When we match up the chart with its numbers. Number 20. Number 20 again asks us to make a graph. This one, they all look fine because I haven't looked at the data yet. All right, so we've got this information here. And the number of actors between 20 and 29 is 0. So when I look at that, it's not A because they have actors in 20 to 29. The number of actors, it looks like the biggest section should actually be 40 to 49. So when I look at 40 to 49, which one has the biggest section right there in that, not quite the middle, but over a little bit? I would say C or D look promising. C or D. But when I look at 50, 60, and 70, we should see it going 6, 4, 2. Should be going down those last 3 from 60 to 80. And when we look at that, that means we're going to rule out D because it actually goes up. We have more 70 plus year olds, but that's not the way our data says. So I'm going to pick C. '21, we have a line graph. This is kind of funky, okay? Before I look at the graph, what we want to look for is, do any of these graphs just look wrong to you? Because there's a couple that look wrong to me. I would say when I'm doing a time series graph, we want years on the bottom, okay? So with that being the case, then I would say A, B, and E are out because the years aren't on the bottom. So let's take a look at what the graph actually said, what the table says, and let's see what it matches. It says in, let's say, the year 1994, the number we got should be 22. So when we look at our choices between C, would we say that meets there? Yeah, it looks like it's definitely less than 50. So I'll say yes to that one. What about D? I would say yes to that one. And F, I would say yes to that one. Okay. The other thing we're going to notice is that as we go up, it just keeps on going up. Keeps on going up. But it looks like they when they made graph F, they read it left to right. It shouldn't go zigzaggy like that. So we need to pick between, now we're just down to C and D. So let's see what's different about C and D. Well, one of them is straight, C is straight, and D kind of has this curve. So in order to tell that, what we're going to look for is, let's look for 2 points that look really different. For example, 2006 should be 219. And when I look at C, 2006 is less than 200. So I'm going to say it's not C. I'm going to go with D. Or sorry, it's not D, it's C. I'm doing that backwards. C, because it swoops down, it's missing that point. So I think when we look at the point 2006 and 219, what we're going to see is it's got to be C. There's 2 parts in this one. The second part says, hey, is this linear? Well, compared to D, C is pretty straight. It doesn't vary much. It goes pretty much straight straight over the entire time series. I wouldn't say it has faster than linear growth. It's got linear growth. And it shows straight line growth, and it appears to be faster toward the end. That's not what when I look at C, it doesn't appear to be faster. So I'm going to say that it shows straight line growth over the entire series. I wouldn't say it varies greatly. It's kind of going pretty steady. So I'm going to try D. I'm not 100% sure, but I'm going to go for D. Yay. Let me hit you with one more before I go today. Question 22, the frequency table. And what it wants to do, it's got 3 parts. First thing it says, are they qualitative or quantitative? So when we look at this, qualitative, quantitative. Well, what's the difference? Well, qualitative data is categorical, and quantitative is numerical, something you can add up and whatnot. And when we look at this, I'm going to say it's numerical. We've got some categories that they're falling into, but I'm going to say it is quantitative. I get nervous when the first thing they ask me is the final check. So the next thing we're going to notice is in the year 1960, men have a higher number than women. Okay, so it says draw a bar graph. So I'm going to rule out it's not A and it's not G because those aren't bar graph. But it actually says draw a bar graph if it's qualitative. Did we say it was qualitative? No, we said it was quantitative. So it's going to be A or D. Which one starts with men being higher and then women taking over? And that's going to be D. Check that. We got 1 part remaining. So what does that tell us? If we look at that graph, we say over time, more bachelor's degrees were conferred to both men and women each year. That's true. They went up each year. The ratio of degrees conferred to men remained fairly constant. Well, that's actually not true. The ratio actually changed a little bit. Over time, more bachelor's degrees were conferred on both men and women. In the 1960s, more were being conferred on women. By the 80s, more were conferred on men. That's backwards, I think. Over time, more bachelor's degrees were conferred on men and women each year. In 1960, more were for men. And by the 80s, more were conferred to women. I think that sounds accurate. All right, homework 4 is big, so I'm going to leave you right here. I'm going to let you finish it.